Good afternoon, everyone. So, how are you doing? Great. Yeah. I think we are doing great too. I don't know how Samip is doing, but I'm doing great.
Yeah, we have snacks after this, right? So I'm waiting for that.
Yeah. So coming in today, me and Samip will be talking about like how we have scaled our recommendation systems. Our recommendation systems used to be like uh, batch, all batch systems, and we have got in Kafka and we got in like real-time machine learning tools, and we have made all our real recommendation system session aware. And we'll be talking about like we'll be talking about like how those recommendation systems have scaled in Credit Karma to give little insights about like how much recommendations are useful in Credit Karma. Like entire Credit Karma's revenue model is dependent on the recommendations we serve to users, and our entire revenue model is based on how good recommendations will be served. So every change in recommendation will serve a lot of will serve a lot of revenue to Credit Karma. So recommendations are like heart of Credit Karma. So introducing about myself, I'm Naresh. I've been with Credit Karma for over 10 years, and I've been in forefront of all the data transformations that happen in Credit Karma. Initially, when I joined Credit Karma, the entire data that we had was around 1 terabyte. Now we ingest around 350 terabytes a day, and we have around 30 petabytes of data that is residing in our data warehouse. So it's been quite a bit of journey. I'll try to get over a few of the things that we learned over this 10 years. I'll hand it over to Samip now.
Yeah, guys, I'm Samip. I have been partner in crime with Mr. Naresh in some part of scaling recommendation system. Prior to that, I mean, I have had experience in building recommendation system in multiple domains. You all are aware. I mean, retail, fintech, marketing, everyone would use it. I have worked as a staff data architect, advising companies like Apple, Cisco, Unilever on their data platforms. So it's a good forum for us to talk about it. The journey which we are going to take you through is more about, and this is something what we met Bhushan while we were having lunch, right? And Bhushan, we told Bhushan we have a 45 minutes material. And Bhushan was like, no one is going to hear you for 45 minutes, right? So cut it down to 25 minutes. And 50% of the people might have just entered the room not knowing the agenda. That might also happen. So just go through the journey which you are taking the users through. So I mean, at a high level, the journey which we are going to take you through is more around how a scrappy product becomes an enterprise product, how a scrappy recommendation system becomes an enterprise recommendation system, and the value of data behind it. So I mean, what I'm going to tell you more about is a high-level overview of recommendation system. Naresh will go into the data aspect of it, how he built the architecture, and then we'll do the closure, right? Yeah. So we have 3 pillars of recommendation system. Any online recommendation system would primarily have 3 pillars. We talk about personalization at the core. Personalization can be at many grains, right? Serving a right offer at the right time. But what is time? Time can be what we have context of the user in last 1 day. Time can be what the user is intending right now in this particular moment. And this is where in-session context comes into play and how you collect that data. And this is what Naresh would be going through, right? Since recommendation system is in the core of any mission-critical application to generate engagement and revenue for your members, reliability becomes an important aspect for it. Latency becomes an important metric, so how do you architect it? And how do you make the data systems, the downstream systems and upstream systems also reliable enough, which are always available, always on? And this has to be done at the lowest dollar cost possible. We have storage which is kind of decreasing, $23 per terabyte. It used to be long back, which has decreased now. If we talk about object storage, compute is also getting cheaper, but scale is increasing, 30%, 40% traffic kind of increasing year over year. So how do you keep on delivering value, but while also controlling the cost of it, right? So these are the 3 principles for any personalization system at the minimum, which they would have. Next slide. Do you want me to click it? Yeah. So here, I mean, everyone might have heard about retrieval. There are three primary steps: retrieval, scoring, and ranking. The goal of retrieval is primarily get the least number of candidates which would be needed for ranking. And I mean, scoring is one of the costliest step within the recommendation system. So you might want to kind of minimize the number of candidates which you are sending for scoring. We would end up using, I mean, ANN, similarity. We will run eligibility search. We'll do multiple things here to kind of just reduce the number of candidates which should be sent for scoring. Scoring will end you giving predictions around, at a high level, around, in fintech, I can say, hey, what is the estimated credit limit for this particular member if he gets approved or she gets approved or they get approved for this offer, right? Scoring will also give you inference around the objective function. Objective function is built around 4 funnels which we have in marketing: impression to click, click to application, application to conversion, right? Based on the score which you'll end up getting within the objective function, you will end up ranking it. You will sort it, rank it. You will have other rules as well, like partner diversity, many things. So at the core, which you see at the top and the bottom, right, data becomes the base. So more and more data which you have, variety and velocity and point-in-time data, more context you have of the intent of the system. And these recommendation systems also generate a lot of data. So logging also becomes a critical part of it, that how do you log this data, which can be utilized across for other use cases, which we'll go into detail later on. This all is done as an experiment. You do not kind of have a blast radius. We kind of launch a new feature to everyone. So yeah, A/B testing experimentation is one of the horizontal for it. And this is one quote. I wanted to put a quote, so I put a quote. History is a hint. Session is the signal. so we can collect all the batch data, but what is happening right now, that's the real-time signal, which we would want to kind of work on. And now I think Naresh would be going more into, specifically into the architecture, which his team has built, which we are able to consume.
Yeah, thank you, Samip. So Samip has been talking about like how recommendation systems work, but without data, recommendation systems are not that useful. As he was talking about, like feature data is one of the critical attributes for recommendation system. Let's talk about like how we have evolved there and how we are creating feature data so that Samip's team can build on top of it. So overall, like when I started at Credit Karma, like our entire recommendation system was based on SQLs. Like we had some set of SQLs, and we used to run those set of SQLs in our MySQL DB, and we used to power recommendations. We were at that point like 10, 12 years back, and it was generating $1 billion in annual revenue or whatever by just running SQLs. But like as our traffic volume has increased, or like as our users have increased, we were seeing bottlenecks. That's when we started thinking about like building a data warehouse. Then we started building data warehouse, and we have built a data warehouse, but and we have built all our feature generation happens in batch, or like all our feature generation happens inside of data warehouse. As our feature generation is happening inside of data warehouse, our models which are running in online system doesn't have historical context. They doesn't have like they only have historical context. They don't have current session context. Most of the times, our batch processing takes around 24 to 48 hours to come back to our feature store. So all this process is like time consuming, and it was taking a lot more time. And at the same time, when we initially designed our tracking applications, or like our user tracking applications, we were relying on Amplitude. Amplitude doesn't give, back then, I don't know how Amplitude works now, but like back then, Amplitude didn't have a way to connect events to a session. So there was no easier way where we can do a session-based analysis, even in the offline world. And conversion impact. As we were doing all recommendations based on our batch data, like for example, I'll give an example, right? Like you are interested in an offer, and you clicked on an offer and you applied an offer. But like when you log back again, or when you go into another other experience, you don't see you might see the same offer again. That's a very bad experience, and that basically has a conversion impact. Because of all of this, we felt that there is a need of there is need of building and redesigning the entire streaming architecture. That's when we thought like we'll redesign the entire system, entire streaming architecture. This was like way back in 2018, 2019. We started redesigning our architecture. So first we started with our client-side modules. We want to get rid of entire amplitude tracking that was running in our system. So what we have done is like we have built we have built a client module which can work for all platforms, right? When we were using Amplitude, we had like different kind of events generated from different platforms. Web was having in one format, like native was sending the data in one format. Like, so we wanted a comprehensive view of all the events from all the platforms, and that's where we decided to build client-side tracking. We'll go in depth into each and every section, and we also wanted to build a real-time processing pipeline. That's when we got in Kafka, and we started thinking about real-time processing pipeline. And the same way, we wanted to have a recommendation engine outside of our SQL engine. So we started working. Like Samip's team started working on recommendation engine. So going in depth into each and every section, like here, coming into client-side tracking. So it's basically, we wanted to track each and everything what happens on our app. So basically, we started tracking a lot of page views, a lot of impressions, a lot of clicks. And these are used for recommendations. But we also wanted to capture a lot of things which are engagement metrics. Like we wanted to capture like what's the dwell time, what's the scroll pattern of a user, and what's the scroll depth, and what's the time he's spending on each site, each page. So we wanted to capture all of those, and we have built a comprehensive framework for that. But everything will come down with a cost. So when we are doing this, we were ingesting a lot more data, and our backend servers were having rate limiting issues. So then what we have decided is we decided to have a cache built in across the platforms, like where this logging happens asynchronously, and this cache basically, this cache is used to replay the events whenever there are failures. So this helped us a lot, because when we were using Amplitude, we were seeing like around like 30% of events that are being dropped. We right now have like less than 3% of events that gets dropped. Like these are the events that we get from client side. Only 3% of data being dropped from the client side event is like very significant because of the things that we have built. So when building the front-end systems, or like front-end client module, the most important thing that we had into account is like how can we have session continuity. Like as I was talking about, our previous iterations doesn't have a unique session to link all the requests inside of session. So we have integrated our session ID with auth token. So most of our experience is authenticated. So auth token had our session ID. So all the requests that we are getting from the front end clients always had session ID. We also made use of cookie ID and device IDs to interlink the events across the sessions. So in case of native devices, we use device ID to do intersession analysis. And at the same time, we have also built in privacy. Basically, we have consent management from the user and all that implemented. On top of all of it, like data governance is really important. So we have like really good data governance implemented, because for developers, tracking like this is basically logging for developers. They don't care about it. So what we have done is we have built extensive unit testing frameworks. Like before any change goes into production, there will be some smoke tests and there's some integration tests that will be running, and that will be checking whether all the clickable elements or all the viewable elements are triggering the events or not. So we have built a comprehensive framework for that. And the most important piece is our scalable data infrastructure. I really want to credit Jason here. He's sitting here. So he's the one who built our Kafka cluster. So our Kafka cluster initially was like just like 500 GB a day. Now it's around 350 terabytes a day, and that's only possible because we were able to scale our Kafka cluster. And all the data that we get from client side are basically logged into this Kafka cluster that we have. And all the data inside of this Kafka cluster, most of the data is not partitioned, but the important data is partitioned either by session ID or a request ID or a user ID based on the data. Yeah. So now we got the client-side data in here, but like there are a lot of challenges. This is still not complete picture of what we need, because this is all siloed data. We only have the client-side interactions where user clicked on it, user did this, user did this. But for us to really use this data in models, we need to have more context about user. So how did we build that context? So the first thing what we did was like, when a request is served, there are tons of microservices which are running in the background. And microservices have a lot of data. Microservices power a lot of data into our product experience. We wanted to log all the data from all the microservices. But this is like too much overkill for services, because services has to implement some custom logic to log the data. So we have built something called declarative ingestion, where services can instrument, or like services can annotate their service contracts. If they annotate their service contracts, their request and response will be automatically logged. And we also have tracing implemented in our system, and every request that gets logged, or every response that gets logged is assigned with a request ID, which is generated by our tracing systems. And this request ID is also propagated from front-end systems. In this way, we have created a unified stream inside of our Kafka cluster. So all the data that gets ingested and that is required for user behavioral analytics is there in our Kafka cluster. So every day we collect around 350 terabytes of data sitting in there, and we have like 7 days retention to replay our data. Now we have data sitting in our Kafka cluster. How do we process this data? So we have done a lot of, I want to give a little history here. We have done a lot of things to process data. Like first, we have initially when we started, we have used Spark to process this data, and we were not successful because we have to provide this data within like less than a minute, because this is used for session analysis. And then we tried with data flow, we were not successful. Later, what we have done is we went back to vanilla Kafka consumers, wherein we have built consumers. We have built consumers to read all backend data and put it into a key value store. We use Google's big table as our database. Like we read all the data that is there from backend services, and we put it in our key value store, which is Google's big table. And what we do is like when we put there, our row key is usually a request ID or a user ID or a session ID based on the type of the data. Now, what happens is when we have an incoming request from the front-end clients, based on these IDs, we basically join all the data from the Google's big table, all the data that we have saved in Google's big table, and we basically create a comprehensive event with all of it. So to explain here, like it's a complex data model. For some of the events, it joins around 20 tables, and all of this happens in seconds. But like this was solving our purpose, but like it had its own challenges. Now the biggest challenge here is when the consumers which are running from Kafka into big table, if those consumers have certain lag, what's going to happen is it's going to break down the entire process, because there will be a lot of failures around it. So we have built a lot of mitigation strategies, like we have implemented dead letter queues, we have implemented retry methodologies, we have also implemented ways in which the lag of consumers can be automatically, the consumers can be automatically scaled, but we were not able to, because of the infrastructure that we have in CK, we are still figuring out a way how that can be automatically scaled. So I mean, as I was talking, Jason knows all these pressure points, because we always involve him. Even if we have a small issue with Kafka, this will get impacted. Yeah. Going into next slide. So now we have all this data, right? Like having this data is useful, but like we have to create meaningful features so that Samip's team can read out of it. So right now, what we are doing is, right now, this feature engineering was basically also it's a data flow job that we have on top of Kafka, which reads this complete view of data and generates features out of it. There are different kind of features that we create. I've listed in the slide. I'm not going to go in depth. But like right now, we are in the process of moving away from this data flow job to Chronon. Like basically, Chronon, I don't know if you guys are aware, Chronon is a streaming, it's a feature platform where you can pass on, feature sequels as a config, and features will be generated on the fly. So we are in the process of migrating our data flow job, which was taking quite a bit of time. Into Chronon. So overall, by doing all of this, we were able to reduce our latency from like 48 hours to a minute. And our SLAs to the external teams is 5 minutes. But like within our team, we have latency about a minute. Now I'll hand it over to Samip to talk about like how is he using this data.
Yeah. So I mean, Naresh touched upon the Chronon part, right? One of the bigger problem when you operate at scale is also you have a data scientist, they would want to kind of update the feature, and if they go through the regular bureaucratic process, getting that feature in or trying that feature out would also kind of take a longer time, right? So that's how you simplify feature onboarding, which is available ASAP within the feature store, which can be tried out and is also available for production run, right? So one part is so online recommendation system. It generates data. It leverages the data which a complex data platform has kind of created, and we also generate a lot of data. So that's where the symbiotic relationship which we have here. Once the recommendation is generated, an important part of it is retraining the models on the latest labels which we had seen. Even though it's fintech world is also moving faster and faster. You have social events, you have YouTube videos now, vloggers, everyone. A simple vlog from them kind of changes the user pattern. There is also a study out there, an established study. I have not taken a permission from them to quote them, but the study is more around that if you do not retrain your data for 7 hours, you lose your precision by 0.7%. That's a very high level of precision which you are losing. So how can you also make the data available in real time, near real time for retraining is also a challenge which we have worked together to solve this. It's passed to model data store. He mentioned about joining all the data, creating a semantic layer, having a model store which is also there, different model families, catalogs of model families, retraining those models. Another aspect is logging. We have SRE team, Mithul, Mr. Mithul, who kind of keeps us honest, making sure each and every data is being logged, and we are able to kind of, as soon as there is an event, because it's one of the critical system of the experience. As soon as the system is down, you are able to debug within 5 minutes, 10 minutes, or you are able to kind of identify where the issue is. So it's not a black box. So having the data available in 5 minutes is also a very important aspect which we have, right? Data drift, we will have concept drift is something which can happen. So refreshing the data there, which comes into play. We also have a GenAI app, which we internally call RecLens, where anyone can ask questions, because it's a good source of truth. It's a grounded truth around how a recommendation was created, and you can ask questions around anything to this data. And see why a model was performing like this, or many things, which we can kind of ask, even at the services level, which you can ask here. So yeah, this has been our journey, where we were able to start scrappy, we were able to scale. Did you say 300% increase in data over the time?
So I didn't remember what was days volume when we started, because it was 500 GB overall. Now we have 300 terabytes a day, 350 terabytes a day.
So yeah, the exponential scale. So it's not the number, but the scale, which we increase work through multiple teams to kind of get it here. So yeah.
And on top of it, I really want to tell, like, we are doing all of this, and we have only one engineer who is supporting entire Kafka infrastructure at CK. And he's going to give talk next time, basically how we are supporting Kafka infrastructure.
Cool, guys. Thank you.
Yeah.